Hey, fourth graders, Mr. Clean here. We're going to be doing another lesson on hidden arrays. So again, we're going to be looking at kind of arrays and area models representing multiplication problems and thinking how could we divide these into smaller pieces? How could we think of new ways to solve these? And even though we're practicing with smaller single-digit numbers, it's going to really help us as we get into larger and larger numbers, okay? So the first problem we're doing is 8 times 4. So that one way you can think about that is 8 groups of 4. So here I have 8 fours. 1, 2, 3, 4, 5, 6, 7, 8. So one thing I see kids doing sometimes when they're solving a problem like this is they might write it out, all those 8 groups of 4, and then they might kind of start counting 4 by 4, okay? So they might do something like this. You might go like 1, 2, 3, 4, and then write down 4 there. 5, 6, 7, 8, 9, 10, 11, 12. Sorry for my sloppy writing. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, okay? And methods like that totally work. A couple problems can be, it takes a little while, and you can also make some easy mistakes when you're counting, okay? If you're not consistently counting by the right number, or if you get a little bit off, so mistakes can certainly happen, okay? So a related method that I've seen a lot of kids do is they'll kind of start doubling, okay? So they'll say, okay, 4 and 4 is 8. So 2 groups of 4 is 8. Then they'll kind of double all of those. Okay. And then I'll notice kids will then double it again. So they'll do a second round of doubling. 8 and 8, that's 16. And then they'll do a third round of doubling. And they'll add 16 and 16 and hopefully get 32. Okay? So this method is called double, double, double. Okay? So when you're multiplying by 8s, you can double the number, double it again, and double it again to find the total. So here's kind of how it would look looking at an array. Okay? So we'd start with just one group of 4, and that equals 4. Okay. Smaller. All right. So that's this right here, one group of 4. Okay. And then you would double that and take up twice as much space. So that would be, 2 groups of 4, which would equal 8. Okay. And that would look like this. 2 groups of 4, twice as much space. Okay, that's 8. And then double that again. So instead of 2 groups of 4, 4 groups of 4. 4 groups of 4, which is 16. Okay, so this is taking up twice as much area now. So that's 16, okay? And then, I'm realizing I accidentally wrote down plus 16, let's just say equals 16. And then they double it again. Instead of 4 groups of 8, or sorry, 4 groups of 4, they would do 8 groups of 4. So they're doubling their 16 and getting 32. Okay? So that would be the entire array now. Okay, so you see how it got twice as big every single time. We doubled, doubled, and then doubled. Okay, very similar to this strategy that I see a lot of kids doing, where they double up the numbers that they're adding. okay? And just keep on doing that until they've included all the numbers, okay? Let's take a look at how that would look on a number line, okay? So instead of counting by 4 8 times and doing 8 separate jumps, let's see how that would look starting at 0. Okay, this will be 0. Okay, let's add 1 4. Okay, and then let's double that to get to 8. Now let's double that, double the 8 to get to 16, and then double it once more time to get to 32, okay? Instead of counting by 4s, 4, 8, 12, 16, 20, 24, 28, 32, we use the double, double, double method, okay? Here's how it would look on a ratio table. Okay, so if I start with 1, I think this would be easier to do with my pen, actually. If I start with 1, 4, then double that. 2 4s is 8. Okay, so we double that. Let's double it again to now 4 groups of 4, which is 16. And then let's double it one last time to get to 8 groups of 4. So double that 16 to 32. Okay, so that is here. If you're multiplying by 8s, you can think about the double, double, double method. Okay, let's move on to now multiplying by 9. Okay, so multiplying by 9s, that's one of the trickier times facts for kids to memorize. So I'm going to show you a strategy that's called times 10, take away 1. Okay, because multiplying by 9 is really close to multiplying by 10. Okay, you can see here we have 9 groups of 6. Okay, 9 6s here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, you can see what that would look like on the array. See how it's almost down here. It's almost to 10 groups of 6. Okay, so again, I often see a lot of kids counting by 1s 6 times and doing that over and over and over again. They'll go like 1, 2, 3, 4, 5, 6, and then write that down. 7, 8, 9, 10, 11, 12, and then write that down. 13, 14, 15, 16, 17, 18, and then write that down. Okay, but again, we're getting up with larger numbers here. All that counting, you're more likely to make mistakes, okay? So I'm going to show you the times 10 take away 1 strategy, okay? So what this means is you're going to think, okay, maybe I don't know what 9 times 6 is, but I bet I know what 10 times 6 is. Oh, that was so sloppy, sorry. 10 times 6. We've been doing the times 10s for a very long time. It's something you can pretty easily count by 10s, 10, 20, 30, 40, 50, 60. Or maybe you know the pattern of when you multiply by 10, it's like taking the 1's digit and adding a 0 to it. So 6 becomes 60. Okay, so you think 10 times 6 equals 60. Okay. This down here. All right. But now we don't really have 10 6s. We have 9 6s. So we have to kind of like cross that off. Okay. So we're really going to take away not 1. I know it's called times 10, take away 1, but we're taking away 1 group of 6. Okay. 1 group of 6. So it's like we have 60 minus 6. You could count back in your head, 59, 58, 57, 56, 55, 54, okay? Or maybe you know another subtraction method to get minus 6, and that would give you 54, Okay, so that's how the times 10 take away 1 method works. It's like you're adding in an extra 6 here and saying, oh, 10 times 6 is 60, and then going back and saying, wait, no, let's take away a 6 to get to 54. So that's 9 sixes, okay? All right, let's take a look at how it would look on a number line, all right? So let's start at 0 here, okay? We're gonna, instead of just counting by 6s 9 times, we're gonna jump all the way to 10 sixes, okay? 10 sixes, which would be 60. All right. But then we got to remind ourselves, nope, we're doing 9 times 6. So let's go back. Oop, that's the wrong thing. I didn't want to do that. This one. So let's take away one of those 6s to get to 9 times 6. And that would be 54. Okay. Let's see what it looks like down in a ratio table. All right. So we're counting by 6s. So we're going to jump up to 10 6s, which is 60. Okay. So we did times 10 on our ratio table. Okay. Now let's take away 1. Okay. Take away 1. So this is 9 6s. Now, I know it says take away 1, but really what we're saying here is we're taking away 1 6. Okay. Because that's what 9 times 6 means. Remember, it doesn't mean, 9 ones, it means 9 6s. So we're taking away a 6. Okay. So if we got 60, we take away 6 or count down 6. And that would be 54. Okay, so that is a method for doing your times 9s. You multiply times 10, and then you take 1 of the number you're counting by away. All right. Okay, so since we've given you a lot of strategies for multiplication this week, we're going to do a little bit of independent practice today with some multiplication tables. So here's what you're going to be doing. Okay, the first thing you're going to be doing is you're going to be filling in the 4s and 6s on a multiplication table. So this is a multiplication table, just like the ones that we use in class. I know I've talked with a lot of people about them. You're going to try to fill in the row for 4 and the row for 6. So what you'll do is you'll take your pen or pencil, okay, and you're going to figure out what numbers are going to go in each of these boxes. So here we're counting by 4s. 0 4s is 0. 1 4, 1 times 4 would be 4. 2 4s, 2 times 4 would be 8, and so on and so forth. Okay. Then you do the same thing for the 6s. All right. 0 6s, how much would that be? 1 6, how much would that be? 2 6s, how much would that be? Okay. So that's the first thing you're going to do. Then you're going to do this multiplication table where we have lots of things that are missing. Okay. And now what you want to use here are your top and side rows. These are your factors, like your guide rows. So let's say I'm trying to find out what this box is right here. Okay. Well, I see this is in row 5 and column 7. So I could think about this is like saying 7 5s, 1, 2, 3, 4, 5, 6. This is the 7th 5. Okay. Or I could think about this as the 5th 7, 1, 2, 3, 4, 5. Okay. So this is saying 5 times 7, which is 35. Okay. Another way you can think of it, take a look. This is 30 here. This is just one more set of 5. 30 add 5 is 35. Or here, This was 28. And this is in the 7 column. 28, add 7 more would be 35. So use the clues you have around you. Use the numbers that you know already around you to help you figure out the missing ones as well. So I want you to try and fill in all the blanks here. Okay. All right. That is your assignment for today. Good luck. And I'm excited to see what you're able to do. All right.